For decades, Toyota built its empire on quiet strength, the kind of confidence that never needed noise to prove its power. It became the world's most trusted name in mobility, quietly moving millions of people across the globe. But something has changed. In a rare and striking moment, Toyota's CEO stepped into the spotlight with a message that stunned the industry. Our new dynamic force engine will destroy the competition. That wasn't just a challenge, it was a declaration, a signal that Toyota is done standing in the shadows, while others steal the headlines. So, what exactly is this engine, and why is Toyota so certain it will leave everyone else in the dust? Let's uncover the story behind Toyota's boldest move yet. The game plan that could redefine the future of internal combustion. Toyota isn't just improving its engines, it's reinventing how they work for the world that's coming next. The new Dynamic Force Engine series represents a radical rethink of traditional powertrains at a time when most automakers are going all in on electric vehicles. These aren't small tweaks or minor upgrades, they're the centerpiece of a long-term strategy linked to Toyota's Global Design System, TGA, or Toyota New Global Architecture. This platform is what allows Toyota to build cars that are lighter, stronger, and more efficient, and to do it faster and smarter than before. While others rush to abandon combustion entirely, Toyota is taking a different path, one that blends the old with the new. The dynamic force engines are designed to deliver powerful performance, impressive fuel efficiency, and dramatically lower emissions. Even more impressively, they can run on alternative fuels like ethanol or even hydrogen. Toyota's leadership believes the internal combustion engine isn't dead, not yet. In fact, it still has an essential role to play in the global shift toward cleaner mobility. The new dynamic force engines are designed to work with Toyota's TNGA platform. TGA is a system that allows different cars to share the same parts and design. This helps reduce production time and makes it easier to use the same engine in many types of vehicles. For example, the same the same engine could be used in both a small sedan and a larger SUV without needing a full redesign. This system helps engineers focus on making engines better instead of starting from scratch each time. It also allows Toyota to bring updates and improvements to many models more quickly. This approach saves money, reduces waste, and supports future changes like switching to new types of fuel. The dynamic force engines focus on more than just speed or power. They are built to be efficient, reliable, and better for the environment. One of the most important changes is their high thermal efficiency, which means the engine can turn more fuel into usable energy rather than losing it as heat. These engines also use a longer piston stroke and a mix of fuel injection methods to improve performance and reduce emissions. Cooling systems are also more advanced. Electric water pumps and better temperature control help the engine stay at the right temperature. This makes the engine last longer and work better in different weather conditions. Every part of the engine was designed with care to support both performance and fuel savings. The Dynamic Force series includes 3 types of engines: a 3-cylinder, a 4-cylinder, and a V6. The 3-cylinder is small and uses less fuel, which is good for compact cars. The 4-cylinder is the most common type found in many mid-size cars. The V6 is stronger and made for larger vehicles that need more power. Each engine can work with several types of fuel. Toyota is testing options like ethanol and hydrogen. These engines are also designed to work with hybrid systems, so they can be used in both fuel-only and hybrid cars. This gives Toyota many options when building new vehicles. Toyota builds these engines using its global factories. The design allows for flexible production, so the same engine can be made in different countries with local parts. This saves time and money while keeping quality high. It also helps Toyota deal with supply issues or changing demand in different regions. Because these engines follow the TNGA system, Toyota can quickly adjust production based on local needs. For example, if one market needs more ethanol-based engines, Toyota can shift resources without major changes. This kind of flexibility is useful in today's fast-changing industry. The dynamic force engines give Toyota an advantage. While other companies are moving away from fuel engines, Toyota is improving them to meet both current and future needs. These engines are ready for multiple types of energy and work well with hybrid systems. Toyota's vision is to use dynamic force-derived hydrogen engines for niches where battery electric vehicles may fall short, such as long-distance driving, heavy-duty use, or cold climates. So, Toyota has committed to carbon neutrality by the year 2050, and dynamic force engines play a strategic role in that vision, especially over the next 15 to 20 years. Unlike some rivals who aim to phase out internal combustion engines by 2030, Toyota believes a multi-path strategy is more practical and inclusive for emerging markets. In the company's roadmap, dynamic force engines will gradually shift toward exclusive use in electrified powertrains, including hybrids and plug-in hybrids. Pure internal combustion engine variants will slowly phase out as electrification expands. By the early 2030s, most Toyota vehicles are expected to use dynamic force technology in some hybridized form, delivering low emissions and reduced fuel consumption at scale. Simultaneously, Toyota will continue investing in solid-state batteries, full electric vehicles, and hydrogen fuel cells. But unlike competitors who are betting the house on one solution, Toyota is hedging its bets, allowing its dynamic force architecture to act as a reliable backbone for markets that are not yet EV-ready. This hedging isn't indecision, it's strategic flexibility. The global transition to zero emissions will not be uniform, and Toyota's strategy ensures that it has a scalable, efficient, and proven internal combustion engine hybrid option ready to meet customers wherever they are on the path to electrification. The first and perhaps most decisive variable is the pace and geographical equity of global charging infrastructure development. Toyota's advocacy for the continued relevance of internal combustion engines rests fundamentally on a pragmatic assessment of energy accessibility, rather than a denial of electric vehicle technology. Their multi-pathway strategy finds its most compelling justification in regions where charging networks remain sparse, unreliable, or, honestly, just prohibitively expensive. Should a concerted global effort emerge, spearheaded by governments through targeted subsidies, streamlined permitting, and grid modernization investments alongside private enterprises like energy giants, dedicated charging networks, and automotive rivals, the landscape could shift dramatically. An unprecedented acceleration in the deployment of high-power, ultra-reliable fast-charging corridors along major highways and within urban hubs would not merely improve EV convenience, it would systematically dismantle the range anxiety and practicality barriers that currently sustain hybrid and alternative fuel vehicle demand. In this scenario, the total cost of ownership for EVs could undercut hybrids sooner than projected, and consumer sentiment could tip decisively toward pure electrification. Consequently, the commercial viability and technological relevance of advanced internal combustion engine platforms like the dynamic force engine could erode faster than Toyota's conservative roadmap anticipates, potentially stranding investments and compressing their transition timeline. Conversely, prolonged and uneven infrastructure development would powerfully validate Toyota's hedge strategy. This is particularly likely in emerging economies and vast rural territories where grid capacity is limited, capital for public infrastructure is scarce, and logistical challenges are magnified. In these markets, the immediate future belongs not to the socket, but to the pump and the hybrid battery. Vehicles that can run on existing, widely available liquid fuels, including biofuels and synthetic e-fuels, where adopted, or that drastically reduce fuel consumption via hybridization would dominate for the foreseeable future. Here, Toyota's deep expertise in cost-effective, durable, and fuel